Hi class, this video is going to help with 8.2 and we have union, intersection, complement, and odds. So we're still doing more probability. We just have more, we just have more. How else do you say that? More ideas and more concepts to come through. So give me a sec and I will share my screen here. Okay, so the first idea is bringing in those symbols that we learned in chapter 7. If we say we have A or B, it's the same as saying I have A union B, because A or B, you take this set and you combine them together. So they become one. The and is that intersection, right? So it's A and B, or you're going to use the intersection of the two. Okay. So my first example, let's say my sample space is 1, 2, 3, 4, 5, 6, which is just a fair dice. I rolled a fair dice. What is the probability of rolling an odd and exactly something divisible by 3? So how am I going to do this? Well, what is odd is 1, 3, and 5. What is divisible by 3 is going to be 3 and 6. So I'm answering both the questions, and then I look, is it or, is it and, union, intersection? And this one is an and, so we're going to be doing the intersection, right? So which ones are in both? The intersection is going to be just the 3. Okay, so there's just one number, that 3. Then to make the probability, it would be the number in the intersection over the number in the sample space. That's kind of our notation for it. So it's 1 out of 6. Of course, you probably could have got 1 6 without all this, but I have to show you in one that makes more sense before we do harder ones. Okay, so what if we did the probability of rolling an odd or exactly divisible by 3? So we're going to do the or with the same problem. Well, we already know this, the numbers. They're 1, 3, 5, and 3, 6. But this time we're going to take all of them, but you only take the 3 once. So how many numbers are in the union? It would be 1, 2, 3, 4. So there's 4 out of 6, which reduces to 2/3. Okay. All right, so a couple other words. Mutually exclusive is disjoint. The intersection is MC. The intersection is empty. So if I say some things are mutually exclusive, they have nothing in common. They're totally different from each other. Okay, so if they are totally different from each other, then we can take for your or your union, you can just take one plus the other. That's as long as there's none in common. So we can add with or, which we've done before. We can add them with or. The issue is if one affects the other, then this doesn't work. Blah, 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 blah. So the probability of the union of two events is going to be, if they're not mutually exclusive, right? If they have stuff in common, we would add them, but we would subtract off the in common. Kind of like that 3. We couldn't include it twice or we would have had 5 right here. So we want to make sure we subtract that off. So that'll become important as we do more problems. So pause, write these 2 ideas down. Okay, so I roll 2 dice and I add my results. So I can get 1 through 12, or 2 through 12, excuse me, because 1 plus 1 is 2. So, and then 6 plus 6 is 12. Okay, I roll 2 dice, I add the results. What is the probability of getting a 7 or an 11? So we could go back to that chart. Goodness, I had a chart of that we can cheat and use, so I can be lazy. So how are the ways that how many ways can we get the probability of a 7? So there are 6. So we could go back and make the chart, and the 11, there are 2. Or you can write them out like I did here. There are 6. So I do n means number of them is 6, and there's 2 in set B. So these are mutually exclusive. There's none in common. So we would just take and add those two probabilities together. So 6 out of 36, because the sample space is 36, 6 times 6. And we'd add those two and we'd get 8 out of 36. Or you can reduce it. Okay, so again, that's mutually exclusive. What is the probability that both dice end up the same, or that the sum is less than 5 turns up? Okay, so let's look at both again. So the first set we'll call A, and that's both dice are the same. So that's a 1, 1, a 2, 2, a 3, 3, blah, blah, 4, 4, 5, 5, or 6, 6. So there's 1, 2, 3, 4, 5, 6 of those. So the number in that set is 6. And what about the sum less than 5? So 1 plus 1, 2 plus 2, or 1 plus 2, 1 plus 3. But if I did 1 plus 4, that's going to get me 5, and we need less than 5. So then we go to 2. 2 plus 1, 2 plus 2. But I can't do 2 plus 3 because that's 5. And we can do 3 plus 1, and then we can't do 3 plus 2. So those are the only ones. So there's 6 of those. So what we're going to do on this one is we have some that are not mutually exclusive. So the idea is we know we have 6 out of 36, 6 out of 36. For our probabilities, we add those, but we also have to subtract off the 2 in common. Okay, that gives me 10 out of 36. Or you can look up here and count them and only count the ones in common once. But do know this idea because it'll help. Okay. So my next problem here. What is the probability that a number selected at random from the first 500 positive integers is divisible by 3 or 4? These are not mutually exclusive, okay? So how do we know if something's divisible by 3? Okay, well, we're going to there was a couple ways to think this one through. To be divisible by 3, there's 166 numbers divisible by 3. Divisible by 4, there's 125. But then divisible by both, we can find by dividing by those being times. So how do I get how many numbers are divisible by 3? I just divide it by 3. How many numbers are divisible by 4? I just divide it by 4. For both, I have to divide by 12. Okay, so if I wanted the probability of 3 or 4, I would take the 166 plus the 125 and subtract the 41 all over the 500. Okay, which it ends up being a half. That one's straight from your homework. It threw me for a loop at first to think of the both. I was like, well, I don't want to go all the way to 500. How am I going to do that? And I'm like, duh, multiply them, divide it in. So you will have a problem like that one. Okay. Now I lost my, okay, so odds I still got to do, okay, a shipment for 6, 7. Okay, a shipment of 45 parts, including 9 that are defective, is sent to an assembly plant. Oh, we're bringing in some business. You really do use probability in business. Okay, a shipment of 45 parts, including 9 that are defective, is sent to an assembly plant. The quality control selects 10 at random for testing and rejects the shipment if 1 or more is found to be defective. What is the probability it's rejected? Okay, so remember, if I do this little symbol here, it means not in A. So it's like a complement of A. So complement again is like, if it's 20% chance of raining, then there's an 80% chance of not raining. So they're like minusing 1. They're complement of each other. So how many are non-defective? So we would have 36, right? Because that's how many are not defective. And we would choose 10. Isn't that what we said is 10? Yeah, selects 10. So where did I get 36? 45 minus 9 is 36. This is how many ways for us to pick non-defective. Okay? The sample space would be picking 45 out of that 10. Or 10 out of the 45, set it backward. Okay, so we'll get those two numbers on our calculator, and the probability of non-defective is going to be this one over this one, which is 0.08. So the probability of defective is 92, subtracting 1. Oops, you can't see what I just pointed at. There we go. Okay, so non-defective, we put our number over our number. And the probability of defective is 92. Oof, it's pretty high of getting at least one that's defective. Okay, 0.8 or 8% chance of getting non-defective. Wow. I was thinking like it should be the other way, but then I was like, well, there's 9 out of 45 already broken. I feel like that's how Amazon ships you some of their products, right? They throw them all in a bin and they just grab one, and they probably got it from some fake person, and not fake person, but someone who's shipping something naughty. Okay, so what is an odd? So when we go for gaming, I'm just gonna undo this and then I'll explain each one. If we go for, not gaming, wrong word, kind of. If we go to like a horse race, we get odds. The odds, are they in your favor, against your favor? I just want to say, may the odds be ever in your favor. If you do not know that, then you did not read those books and watch the movies as a child. Okay, so odds are used in gaming, and they're for or against, one or the other. So for is the probability of the event divided by the probability of not the event. The against is the probability of not the event divided by the probability of the event. So let's look at this. What are the odds of rolling a 2 on a dice? Well, I didn't really show it there. So what is the probability of rolling a 2, or not probability, the odds of rolling a 2 on the dice? Well, there's only 1 2 out of 6, and odds of, so we're in favor, so we're doing this one, and the probability of not is 5/6. Well, then what happens is we take the 1 6, flip the second one, and the 6s will cancel, and we'll get 1 to 5, which we can write all 3 ways: 1/5, 1 to 5, 1 to 5 with the 2 dots, whatever that's called. I think I don't teach English. All right. Okay. 1/5. They add to the sample space. Add to the sample space. Do you know how many people will put 1/6 on there? Nope. You'll get it wrong. Okay. Odds against rolling a 2. What do? Well, we're going to flip these fractions for against. And we would say, well, the probability of against is 5/6 divided by 1/6. So flip that over, and you get 5/6 times 6 over 1, which is 5 to 1. So it's the opposite, and they still add to the sample space. So the odds against rolling a 2 are 5 to 1. Okay, what is the odds of rolling a sum of 7 in a single roll? So the sum in the single roll of 2 fair dice. Oh, there we go. If we add 2 dice, what is the odds of getting that 7? That 7, remember, is the highest probability. And this one is 4, so we're going to use our probability of the event divided by the probability of not the event. So there's 6 out of 36 chance to get a 7, and there's 30 out of 36 chance to not get a 7. So we times to keep the top one, flip the other, and we get 6/30. That's our odds. Reduce it, and you get 1 to 5. Should we have a lot of 1 to 5s and 5s to 1s. Just happens to be what I picked. Okay, so odds are just probabilities, kind of leaving off your sample space. Okay, so if I go into a game and I'm going to pick a horse on a horse race, and it says this horse's odds are 2 to 3, and it says this horse's odds are 1 to 5, which horse are you going to go with? Well, your probability of the 2 to 3 is, if I add it, I think of it, it's 2/5. Okay, and then the other one, oh shoot, I should have wrote that down, was 1 to, what did I say? You'll laugh at me now, but let's say it was 1 to 5, it would be 1/6. So you can compare those that way if you need to. Okay, so the whole idea of this odds is just dividing the two different ways. I don't think you'll have a hard time with the odds. I think the other ones will be tricky. Now I thought we had a couple problems with the Venn diagrams, but that might be in the next section. Okay, I think that's all that's in this section. So I think the other section brings in the Venn diagram. All right. Yeah, if I need to add another video, I will. There might be a part 2. But I think that's it. That's in the section. All right.